Right. Now the voice, now the streaming is okay. Fine. Now the streaming is clear, it seems. Okay, students. Yeah. So let us discuss this question. Question number 29. It is given that four identical rods, each of mass m and length L, are joined to form a square. The moment of inertia of the system about any side of the square is question number 29, you see. So let's try to draw the pictorial representation of the given scenario or description. Four identical rods, each of mass m and length L, are joined to form a square. Let us consider here, this is one rod, this is another rod, and this is another rod, and this is the fourth rod. So all are identical, guys. Okay, all are having length L and mass m, and they're joined to form a square. The moment of inertia of the system about any side of the square is, let us consider the axis is passing through this side. Let us say this is the first rod, this is second rod, this is third rod, this is fourth rod. So moment of inertia, total moment of inertia of the system is equal to, because four rods are there, moment of inertia of the system is equal to moment of inertia of the first rod plus moment of inertia of the second rod plus moment of inertia of the third rod plus moment of inertia of the fourth rod. Let us say here, as the first rod is such that the axis is passing through the length of the first rod, so the mass distribution is such that no moment of inertia will be contributed for this, because mass of the first rod is lying on the axis. So you can take I1 is equal to 0. If you take, this is equation 1, and I2. So this is the second rod and fourth rod. If you observe here, moment of inertia of second rod should be equal to moment of inertia of the fourth rod, because the axis is passing here at the ends, left ends of these rods, and the axis is perpendicular to the rods, and at the axis is passing through one of the ends. So moment of inertia of this is equal to ml square by 3. ml square by 3. Okay. Whereas I3 is equal to, here every part of the rod 3 is at same distance. So you can say the entire mass is supposed to be at a distance which is equal to L. So we can write it as mr square. It is nothing but ml square. So I3 can be expressed as ml square. So therefore from equation 1, I is equal to, I1 is 0 and I2, I4 if you add together, and I3 also if you add, we will get 2 ml square by 3 plus ml square. Right. So this one, yeah, so in the streaming, if the writing part is not clear, try to change your settings in the video, guys. While viewing, you can click on you can click on the video, and at the right side corner there is settings option, settings icon will be there. Go there and click on that, then you will get some options there. Click on quality. So there, the quality part, you can if you click on data saver, the low picture quality will come. Okay, high picture quality or auto recommended. Adjust, the clarity will be adjusted. You have to select this, guys. Okay, right. So now therefore this gives you what? 2 ml square plus 3 ml square, 5 ml square by 3, or 5 by 3 ml square is I. So this is given in which option? Let us see here. 5 by 3 ml square is given in second option as this one. I hope it is clear for you. Right. Then next question. See, question number 35. It is given that question number 35. Next, let us see question number 35. A helicopter of mass 1000 kg moving with 5% of average mass 65 kg with a velocity of 72 km per hour, then the momentum of the helicopter is. Momentum of any moving object is equal to mass into velocity, right? But in this case, if you observe here, the helicopter is moving. Helicopter is having some mass, let us say capital M, and it is having 5% in this. So each person having average mass, let us say small m, then total mass of the system should be m plus 5% are there. 5m is moving. This is moving with velocity v, that is equal to 72 km per hour. Then momentum of the helicopter is momentum P is equal to mass into velocity. So mass is m plus 5m in this case is 1000. Capital M is 1000 mass of helicopter plus 5 into 65. 5 into 65 is how much? 5 5 is 25 and 5 6 is 30, so 32, 325. So 325. So this is total mass into velocity of the helicopter, 72 km per hour. You have to convert this into meter per second, guys. All should be in SI units while calculations. So you have to write this as 72 into kilometer per hour. If you want to convert it to meter per second, 5 by 18 you have to multiply. How? You have to remember 1 kilometer is equal to 1000 meters and hour equal to 60 minutes into 60 seconds. If you multiply that, simplify, you will get this one. So now on simplification, yes, 9 ones, 9 eights, sorry, 9 twos, 9 eights, 2 fours. So 18 fours, 18 fours, 5 fours, 20. So 20 meter per second is this. So into 20. So this is equal to 1325 into 20. So it will be, which question it is? Question number 35, 35th question. 26500. So it is equal to 26500 is the momentum, mass into velocity. So kg meter per second is the unit of momentum. So momentum of the helicopter in kg meter per second we are asked. So 26500. That's it. Is a direct question, guys. Right. Next, question number 36. Question number 36. Just you can go through this. Nothing is there. This is a simple one. 35th one. Next, 36th one. It is given that two blocks of masses 10 kg and 5 kg connected by a light string, and a force of 50 Newton is applied on 5 kg and pulled. The tension in the string is. This kind of questions, to answer, you have to draw free body diagrams and you have to write equations of motions. How? We have discussed it already. Now you can just go through briefly. Yeah, see, 10 kg and 5 kg blocks. So this is a surface, a smooth surface, let us say. This is 10 kg block and this is 5 kg block. They are connected by a string, and on the 5 kg block a force F is applied. So how much is that? 50 Newton. F is equal to 50 Newton is applied. Question number 36. Okay. Now, just you have to say, you are asked to find what is the tension in the string. Let us say this is the tension T here, away from the point of contact, But let us say the system is moving with the acceleration to the right because force is acting to the right. So you can say acceleration of the system is equal to net force by total mass. Net force is, you can write net force by m total mass. Net force is 50 Newton. Total mass is 10 plus 5 is 15, right? So 5 tens, 5 threes is acceleration meter per second square. You can write 3.33 also. Let us keep this as it is. And this is acceleration. I want tension. So here, if you say this is M1, this is M2. 10 kg block is M1 and 5 kg block is M2. On 10 kg block, only force acting is T. So you can say, if you draw free body diagram and if you write the equation of motion for this, you can say that net force equal to mass times acceleration. So free body diagram of 10 kg, if you draw, you have to mark this as a point object and its mass is 10 kg and the force on this is only, this force is tension in the string only. Because of that, it is moving with an acceleration to the right. So equation of motion can be written for this object as net force is equal to mass times acceleration. So here net force is tension only. T is equal to mass times acceleration. So here this is equal to mass of the body is how much? Taking 10 kg object, so 10 kg. Acceleration is 10 by 3. So it is, what is this question number? 36. Yeah, this one. So we'll get 100 by 3. That's it. So this is tension in newtons. Options are given in decimals. So we have to simplify this further. 3 is 9. Again 3 is 9.3. So meter per second. Sorry, tension, force. So Newton. This is the tension produced in the string. That's it, guys. Very simple. Okay. So go through this also. Next, let us see few more questions which are marked here. So question number 44. It is given that a bullet of mass 20 gram is fired vertically upwards with a velocity of 140 meter per second. So the height to which it rises is. So mass is given, initial velocity is given, height you are asked to find. So here you have to say the height to which it rises, that is the maximum height to which it rises. After rising to that height, it has to be stopped. That is what you have to understand and keep in mind. Then to find this, you have to apply equations of motion. According to this. So question number 44, if you want to see. Question number 44. So try to draw the given, write down the given data once. Mass 20 gram. M is equal to 20 gram. If you see the options, so the height is given in meters, SI units. So all parameters should be mentioned in SI units only. So convert this into SI units. 20 into 1 gram is 10 power minus 3 kilogram. And it is projected with initial velocity U is equal to 140 meter per second. It is SI unit only, no problem. The height to which it is raised means after raising to that height, maximum height, final velocity should be 0. That is what you have to understand. And copy it down. So what is the height raised is the question. So I have to say from the equations, as mass is given and it is moving under gravity, oh, 20 g, bullet of mass 20 g, 20 gram. I am taking this as, yeah, actually you have to use this equation. If I had to be involved, you have to use v square minus u square is equal to 2as. S is nothing but h, you have to find out. So because it is moving under gravity, vertically upward means it is moving under gravity. A can be taken as g, and s is h you have to take. So h is equal to v square minus u square by 2g. For vertically upward motion or downward motion, you have to consider this as motion under gravity. So acceleration should be equal to acceleration due to gravity. So here v is 0, u is 140, right, and g should be always down. So you can take this as it is moving up. Initial velocity of course will be an upward direction positive if you take the sign convention, and a should be down. You have to take a negative sign for this. Then you can write here minus 2g. So it is 0 minus u square by minus 2g. So minus minus cancel, you will get u square by 2g. U is 140 into 140 by 2 into g is 10. This gets cancelled. So we'll get 2 7s 14. So this will be the height raised. So if you observe here, okay, they have given let us check this, guys. The option it is given as 1000 meters. The calculations part, if you say take h is equal to 0 s 7 to 980, 980 you will get yes, so 980 meters. So approximately they have taken as 1000 meters. Approximately this is taken as 1000 meters approximately. So you can just cancellation we are doing it here. Okay, yeah, there it is. Yes, note down this approximate value, it is given here. Yeah, so that's 1000 meters, actually 980 meters, but in the options they have given approximate value as 1000 meters. That you have to consider. That's it. Next, question number 40. That is 44. This is 44th question. Next, 45th one. Question number 45. Question number 45. Wait. What happened? Yes. Yeah. Question number 45. Let us see what is given in this 45th one. So it is given that the torque if f bar equal to minus 2i plus 2j plus 3k acting on a point r bar equal to I minus 2j plus k, about the origin will be the torque, comma, if a force f bar is acting at a point whose position vector is given by this, about the origin will be. That means direct formula it is. So what is that? Torque tau bar is equal to torque by definition moment of force. So it is r bar cross f bar, moment of force. So when these vectors are given in components form, you have to use a determinant method. According to this, if you take I, j, k, components of r and components of f, you have to take in order. Components of r 1 minus 2 1, 1 minus 2 1, 1 minus 2 1. Components of f are minus 2 2 3, minus 2 2 3, right? If you do this now by determinant method, you can take I, this is equal to I into, if you close the first column while taking the I component, then take the what you call the diagonals. So minus 2 into 3, minus 6, minus 6, minus 2 into 1 is 2, minus j into, you have to take negative sign for the second term always, okay? Then if you close that jth column and the column which is having j, if you close, then you will get 1 into 3 is 3, 1 into 3 is 3, minus 2 into 1 is minus 2, minus of minus becomes plus 2, then plus k into, if you close the column under k, then you will get 2 into 1 2, minus 2 into minus 2 is plus 4, so 4 you have to take. So this gives you minus 8i minus 5j, this is minus 2k, minus 2k is tau bar in components form. Cross check the options, minus 8 minus 5 minus 2, 45, minus 8 minus 5 minus 2, minus 8i minus 5j minus 2k. So third option is the right one for 45th question, right? That's it, very simple one. So within half minute you can do it. So all these questions, if you do the enough practice, you can answer the questions within 1 minute, within the stipulated time or given time you can do happily, but the practice is required, guys. Right, next question number 49. Let us see question number 49. What is given here in this question number 49? It is given that 3 discs, each of mass m and radius r, are arranged as shown in figure. The moment of inertia of the system about axis AB. So here if you observe, actually if you say this is the first disc, second and third, the axis is passing through the tangent lying in the plane of the discs for 2 and 3 discs, but the axis is acting as a diameter for the disc 1. So total momentum of the moment of inertia of the system is equal to moment of inertia of the first body plus that of the second body plus that of the third body you have to take. Now how can you do this? Let us see here. Right. Question number 49. Yeah. 49. 3 discs are arranged like this, another disc like this. So they're arranged in a plane, horizontal plane, let us say, on a table. So 3 discs, each of mass m and radius r, so identical discs, all are having same mass. Let us say this is that axis is passing through like this. This is the axis. This is the axis, guys. So this is axis AB. So this is the first disc, this is the second disc, this is third disc. So you can write moment of inertia of the system is equal to moment of inertia of the first disc plus moment of inertia of the second disc plus moment of inertia of the third disc. So moment of inertia of the first disc here is, because the axis is acting like a diameter for this, moment of inertia of the disc about its axis is mr square by 2. You have to remember this basic formula, guys. Then about the diameter, if you want to find, you have to use perpendicular axis theorem. According to it, I1 is nothing but m r square by 4, m r square by 4 about the diameter, about the diameter, about the diameter. Here this axis AB is acting as diameter for this disk. Next, for second and third, axis is acting like a tangent lying in the plane. So here you have to use parallel axis theorem. So you have to consider here one axis passing through center of mass, and this is passing through center of mass, and it is acting like a diameter. So according to parallel axis theorem, I2 should be equal to I3 is equal to ICM plus MA square. MA square. Here A is perpendicular distance between the parallel axis. It is nothing but A. Here A is nothing but radius of the disk. So you can take it as MA square is nothing but MR square, and ICM is moment of inertia about the diameter, is nothing but MR square by 4 only. So you can take this as this is equal to mr square by 4 plus mr square. A is r, so mr square, and simplifying you'll get mr square. If you take out 1 plus 1 by 4, 4 plus 1 5 by 4, mr square. So I2 is equal to I3 is equal to 5 by 4 mr square. Now if you take the initial one as equation 1 I, now total moment of inertia of the system is equal to sum of these moments of inertia. So therefore equation 1 you can say I is equal to I1 is mr square by 4 plus I2 and I3 are equal, so you can write 2I2 or 2 into 5 by 4 mr square. So let us take mr square by 4 out, mr square by 4 out. For simplification purpose, don't cancel, take mr square by 4 out, then you will get 1 plus 5 into 2, 10, so it is 11. So 11 by 4 mr square, which is this question number 49. Question number 49, if you see, this is the one. 11 by 4 mr square, option 4 is the right one. 11 by 4 mr square. So it is equal to 11 by 4 mr square. So therefore I is equal to 11 by 4 mr square. Right, so this is how you have to do this kind of questions, guys. Right, I hope this is clear. So go through once again, and if you have any confusions, you can drop me a message so that I will clarify you guys a little more clearly. Okay, then I am winding the session.